Hello grade 9 learners, have a nice day. Welcome back to my channel. For today's video, I'll be discussing to you about joint variation. After watching this video, you will be able to answer the following questions. First, how to determine joint variation. Second, how to translate joint variation statements. Third, how to solve worded problems involving joint variation. Now let us try to understand first about joint variation. Joint variation describes a situation where one variable depends on two or more other variables and varies directly as each of them when the others are held constant. Actually, joint variation is almost similar with direct variation. The only difference is that in joint variation, one variable is dependent to two or more other variables, while in direct variation, one variable is dependent to only one variable. That is the main difference between the two. But as far as the trend is concerned, they are both increasing or decreasing. Next, the statement y varies jointly as x and z means y is equal to kxz, or k is equal to y over xz, where k is the constant of variation. Now let us consider the table of values for a joint variation. Consider the area of a triangle, which is obtained from the formula A is equal to 1/2 AB, where A here is the area, where A, the small a, is the altitude, and B is the base of the triangle. The first row is the values of the altitude, the second row is the values for the base, and the third row is the values for the area. In here, area is dependent to the two other variables, the altitude and the base. This is almost similar with direct variation, but the only difference is that for direct variation, one variable is dependent to the other variable. But in here, one variable, in here we have the area, is dependent to the two other variables. And the two other variables here are the base and the altitude. But try to take a look. The trend of the area is increasing. Okay? As the number of altitude and base increases, the area also increases. So there is what we call direct variation. But try to take a look at the value of the base. Here we have constant 3 and 3, and then the altitude is being increased. Still, the area increases. Also here we have constant value for base. While the altitude increases, the area still increases. And also here, the value of the base is still constant, 7, 7, while the altitude increases, the area also increases. So this is one of the characteristics of joint variation. Almost similar with direct variation, but the only difference is that one variable is dependent to the two other variables. In here we have base and the altitude. Now let's have the translation of joint variation into equation. But before that, remember this. Y varies jointly as x and z is being translated as y is equal to kxz. We have here y variable is on the left side of the equation, and then don't forget to write k, and then the two other variables we have x and z. Now let's have the example. Number 1. M varies jointly as n and p. So m is on the left side of the equation is equal to, do not forget k, and then the two other variables we have n and p. So we have m is equal to k and p. Number 2. The electrical voltage V varies jointly as the current I and the resistance. So we have V on the left side of the equation is equal to K, and then we have here I and the resistance R. Third example, the volume of a rectangular prism V varies jointly with its length L, width W, and height H. Is translated as we have V on the left side of the equation is equal to K, then L, then W, and last is the variable H. Now we're going to solve worded problems involving joint variation. Number 1, if y varies jointly as x and z, and y is equal to 72, when x is equal to 4 and z is equal to 6. Find y when x is equal to 2 and z is equal to 14. Okay, first we have to translate the statement using the variables being assigned. So we have to translate y varies jointly as x and z. So we have y is equal to kxz. Now we have to solve for our k using this equation. Now let's substitute. So our y here is 72 and our x is 4. Our z is equal to 6. Okay, simplify further. Multiply 4 times 6. That is equal to 24 times k. So we have 24k. Just bring down 72. To solve for k, divide both sides of the equation by 24. So 24 divided by 24, that is equal to k, and 72 divided by 24 is equal to 3. So the constant for variation is equal to 3. Now let's solve for y when x is equal to 2 and z is equal to 14. We will be using same equation. Now let's substitute. So our k is already 3. We have now to substitute 3, and our x is 2. Our z is 14. Multiply 3 times 2 is 6 times 14 is equal to 84. So y is equal to 84 when x is equal to 2 and z is equal to 14. Another example. If b varies jointly as c and d, and b is equal to 96 when c is equal to 6 and d is equal to 8. Find d when b is equal to 92 and c is equal to 2. So in here we're asked to find the value of d. So same with example number 1. First we have to translate the statement using the given variable. So we have b, the left side of the equation, is equal to varies jointly. We have k as c and d. So k, c, d. So this is the translation of this statement. Now we have to solve for k using this equation. Then we have to substitute. So our b is 96. Just bring down k. Our c is 6 and our d is 8. So multiply 6 times 8 times k. So we have 48k. Bring down 96. To solve for k, we have to divide both sides of the equation by 48. So 48k divided by 48, that is equal to k. And 96 divided by 48 is equal to 2. So the constant for variation is equal to 2. Now we have to solve for the value of d when b is equal to 92 and c is equal to 2. So now we have to substitute. Our b is 92, our k is 2, our c is 2, we have here, and we have to solve for d. So multiply 2 times 2 times d is 4d, and just bring down 92. To solve for d, divide both sides of the equation by 4. So we have 4d divided by 4, that is equal to d, and 92 divided by 4 is equal to 23. So the value of d is 23 when b is 92 and c is 2. Okay, let's have another example. The area of a triangle varies greatly as the base and the altitude of the triangle. If the area of a triangle is 65 centimeters square, when the base is 10 centimeters and the altitude is 13 centimeters, find the area of a triangle whose base is 8 centimeters and an altitude of 11 centimeters. So for solving worded problem, first we have to assign a certain variable to represent for a certain unknown. So let A, the area of a triangle, B, the base of the triangle, and A is the altitude of the triangle. After that, we have to translate the statement here based on the variables that we have assigned. Okay, the area of a triangle, so therefore we have A is equal to, varies jointly as the base, and the altitude, so we have K, B, A. Area of a triangle is capital A, while the altitude is small letter A. So there should be a distinction between the two if we will be using same letter. Next, we have to solve for the value of K. We are going to substitute the values here in our equation. So our area is 65 centimeters square, so that is 65. Just bring down K, and our B or base is 10 centimeters, we have 10, and our altitude or A is 13. Simplify, multiply, bring down 65. So 10 times 13 times K, so that is equal to 130K. To solve for K, divide both sides by 130. So 130 divided by 130, that is equal to K. And 65 divided by 130 is 1/2 or 5/10. Now, we have to solve for the area of a triangle when the base is 8 centimeters and an altitude of 11 centimeters. We will be using the same equation, so we have to substitute now. Our K is 5/10 or 0.5, our B is 8, and our A is 11. Multiply 0.5 times 8 times 11, that is equal to 44. Therefore, the area of a triangle with a base of 8 centimeters and an altitude of 11 centimeter is 44 square centimeters. Next example. The weight of a rectangular block of metal varies greatly as its length, width, and thickness. If the weight of 2 decimeters by 3 decimeters by 4 decimeters block of aluminum is 18 kg, find the weight of a 16 decimeter by 10 decimeter by 4 decimeter block of aluminum. Okay, we have to assign also the variable. Let W, capital W, as the weight of a rectangular block of metal, L, length of a rectangular block of metal, W, the width, while T refers to the thickness. Now let's translate the weight of a rectangular block of metal varies greatly as its length, width, and thickness. So it is translated as W is equal to KLWT. Okay, again we have distinctions between capital letter W and small letter w. So we have to solve for K. Let's substitute it to the equation. So W here is 18. Just bring down K or L, 2, And then our width is 3, our thickness is 4. Next, multiply. Just bring down 18. So 2 times 3 times 4 is 24 times k, so we have 24k. To solve for k, divide both sides of the equation by 24, and we have now the value of k, which is equal to 75 hundredths, or that is equal to 3/4 in fraction. Now let's solve for the weight of the aluminum with a dimension of 16 by 10 by 4. We will be using the same equation, so we have W equals KLWT. K, substitute. This time our K is equal to 0.75. Our L is 16. Our W is 10. And our T is 4. Multiply all together, then the answer is 480. Therefore, the weight of a 16 decimeter by 10 decimeter by 4 decimeters block of aluminum is 480 kilograms. Last problem. The amount of oil used by a ship traveling at a uniform speed varies slightly with the distance and the square of the speed. If the ship uses 200 barrels of oil in traveling 200 miles at 36 miles per hour, determine how many barrels of oil are used when the ship travels 360 miles at 18 miles per hour. Okay, we have to assign a certain variable. A, amount of oil used by the ship. D, distance traveled. And S, for the speed. Next, translate the statement. The amount of oil, so we have here A is equal to K, constant of variation, D, distance, and the square of the speed. That's why we have here S squared. A is equal to KDS squared. Now, let's solve for K. Substitute. So, our A here is 200 barrels. Bring down K. Our T is 200 also, 200 miles. And our S, or the speed, is 36. We have to simplify first 36 squared. So, just bring down the other values. So 36 squared, that is 36 times 36, that is equal to 1,296, and this will be multiplied by 200 and k, and the result is 259,200 k. So multiply 200 times 1,296. To solve for k, we have to divide both sides of the equation by 259,200. So 259,200 divided by 259,200, that's already 1. So we have already k. So this time, since the value is very small, so I just express this one in fraction. So I just reduce this to lowest term. So the lowest term is 1 over 1,296. How did I get this one? 200. The greatest common factor between the numerator and the denominator is 200. And this one will be divided also by 200. So 200 divided by 200 is 1, and 259,200 divided by 200 is 1,296. Okay, I just leave it here because the answer for this is very small in terms of decimals. Okay, next, so we have here to solve for A using the same equation. Our K this time is 1 over 1,296. Our D is 360. And our S is 18. So simplify first 18. So 18 times 18 is 324. Just bring down the rest of the values. Okay. We have to multiply 360 times 324, and the answer is 116,640. Just copy the denominator, so 1,296. 116,640 divided by 1,296, that is equal to 90. You can also apply the shorter method, wherein you can factor out 1,296. Common factor is 324. So we have here 4. Because 324 times 4 is 1,296. So we can cancel out 324. Okay? Because they are common factors. 324 and 324 is already 1. So what are left are 360 and 4. 360 divided by 4 is also 90. But it's up to you if you're going to multiply this. But the solution that I have shown is I multiply 360 by 324 and divide it by 1,296. But the shorter method for this is we have to factor out 1,296, and one of the factor is 324. And then we have to divide the common factors. So divide the 360 by 4, we come up again with the same answer, which is 90. Okay, so therefore 90 barrels of oil will be used when the ship travels 360 miles at 18 miles per hour. Thank you so much for watching, guys. If you learned, kindly comment, and if you have questions regarding the video, kindly write it in the comment box. Kindly share it to other grade 9 students for them to learn or master the lesson. Please don't forget to subscribe to be updated for more math lesson videos and turn on the bell for notifications. Before I end, let me share to you one of the verses from the Bible. Blessed are the peacemakers, for they shall be called children of God. Matthew 5 verse 11. That's all for today, and God bless you all.